In this video, we will show and explain how to successfully answer a problem dealing with waves on strings. In this problem, you will have to use your previous and new knowledge to rearrange and create an equation that solves and answers the problem at hand. Follow along as I read the example problem aloud. A 0.8 kilogram cord is stretched between two supports, 7.5 meters apart. When one support is struck by a hammer, a transverse wave travels down the cord and reaches the other support in 0.64 seconds. What is the tension of the cord? I know what you're thinking. How am I supposed to solve for tension when I don't even know where to start? Relax and don't worry. This might seem tricky at first glance, but let's take it step by step and you'll find that it is not as difficult as it seems. To start, let's write down our known values from the problem. The problem states that the mass of the cord is 0.8 kilograms, so we will write 0.8 kilograms for our mass, or m. The problem also states that the distance between the supports is 7.5 meters, so this is our length of the cord, or L. In the problem, we are also told that a wave travels across the cord in 0.64 seconds, so this is our time, or t. This problem deals with waves on strings. We can tell that this problem deals with waves on a string because the problem states that it is a cord stretched between two supports. Since it deals with this topic, we can use the equation speed equals the square root of tension divided by the quantity of mass divided by length. This equation can be seen on the right side of your screen. This equation only works with waves on strings, so do not try to use this on any other problems. Now that we have written down our known variables and have selected the equation we want to use, let's rework and rearrange the equation to find what we need. We know we want to find tension, so let's look at the other variables in our equation. We have mass, length, but the speed was not given to us. To solve this problem, we must recall the simple equation. Speed equals distance over time. In our case, speed would equal length over time, as length is also a unit for distance. We can plug this in to get our new equation as shown in step 2. In order to work with the right side, we must square both sides of the equation to get the result shown in step 3. Now we have tension divided by the quantity of mass divided by length equals length squared over time squared. To solve for tension, we need to get it alone. We can multiply both sides of the equation by the quantity of mass divided by length as shown in step 4. After simplifying and canceling similar terms out, we get the equation tension equals mass times length divided by time squared, as shown in step 5. Now that we have derived our equation, we can simply plug in our known data. Remember, mass is 0.8 kilograms, the length is 7.5 meters, and the time is 0.64 seconds. After putting the numbers into the equation, we get 0.8 times 7.5 divided by 0.64 squared. Once we put the numbers into our calculator, we find that tension equals 14.65 newtons. Congrats! You have successfully solved a waves on strings problem that seemed difficult. Remember, the equation speed equals the square root of tension divided by the quantity of mass divided by length can only be used when dealing with waves on string kind of problems. Thanks for watching and good luck on future problems.